of water in Epsom salts, and the procedure and purposes for the lab. So the purpose of this lab, as stated in your packet, is to determine the formula of Epsom salts. In other words, we want to know how many moles of water there are per moles of magnesium sulfate. Epsom salts are what we call a hydrated compound. And when I look at the formula for this, this is all the reactant. This is not magnesium sulfate plus water. This is magnesium sulfate times a certain number of moles of water. So this is all the formula for the hydrate. We, in our lab procedure, are going to decompose or break that down into the individual salt, or anhydrous, the magnesium sulfate, and a certain number of moles of water. And this relates to what we've been talking about, because if we want to know the moles of water, we can't measure the moles of water, but we could probably figure out how many grams of water were produced as a result of that decomposition and convert from grams, the data that we're collecting in our lab, into the number of moles. So the procedure for this lab is very straightforward. There's some background information about damp rid, an example of an anhydrous that is able to absorb quite a bit of water. You're going to be using a crucible lid, a crucible tong. Make sure you have your ceramic square out from the cabinet to place the hot equipment on. The ring stand with iron ring, and here's your little clay triangle. You can see it in the photograph. That should hold your crucible rather snugly. And the procedure talks about leaving, while you're heating it, leaving the lid of the crucible just ajar or tipped a little bit so that that water can escape. So if you think about it in the big scheme of things, if we want to decompose this, when we heat it, we're going to be left with the anhydrous, or a solid, dehydrated, if you will, salt in that crucible after heating it. And the water, as a result of heating, is going to form water vapor and is going to be lost, if you will, to the atmosphere. So let's take a look at how what the data table is going to look like. You'll notice from the procedure that the first thing you're going to do before we add any Epsom salts and actually start a procedure where we're collecting data is we're going to do an initial heating, obviously, and then cooling before we put it on the balance. But we're going to do this initial heating just to get rid of any oils or moisture that might be on our hands that might alter the mass of actual water in our hydrate. So I'm going to do this initial heating and cooling and then take the mass of the empty crucible and lid. And I'm then going to add some Epsom salts to there. Your lab procedure says somewhere between 2 and 3 grams. The only reason for those parameters is to make sure we don't add so much that we can't get it dehydrated, if you will, or drive off all that water within a lab period. I can obviously subtract that to get the mass of just the Epsom salts that I added to begin with, somewhere between 2 and 3 grams. We're going to do an initial heating then. This is again separate than this initial heating that we did before we added the Epsom salts, but we're going to have our Epsom salts in there. We're going to heat it for a few minutes, let it cool and mass it. And then we're going to heat it for a second time with the Epsom salts in it because we want to ensure that these two values are within 0.02 grams of each other. In other words, if this mass after that second heating of the Epsom salts is much different than this mass, it means there was still water in there and I was still losing that water to the atmosphere. And obviously for accurate lab data, we want to make sure that decomposition is complete and all of that water has been driven off. I can use this data then to simply calculate my mass of water. So how does this all fit together with what we're studying in our unit? Let's take a look at the pre-lab question that you're going to do. Remember, this is our initial lab question. We're using Epsom salts, which is a hydrate of magnesium sulfate. Your pre-lab question asks you what the equation would be for a hydrate of copper sulfate. It's the exact same kind of procedure. We're just going to work with some sample lab data here. So remember, the goal is to figure out the mole ratio of water, the mole ratio of water to salt. And if I started with 3 grams of copper sulfate, and after I drove off all this water by heating it to constant mass, and I was left with a mass of 1.92 grams of solid anhydrous in my crucible, the difference between those two masses, the lost mass, if you will, would be the mass of water. So now, once I know the grams of water that were contained within my original hydrate, I can take that lab data mass of water and convert it from grams of water to moles of water. And I can do the same thing with my copper sulfate. If I know how much just copper sulfate salt anhydrous was left, I can use the molar mass of copper sulfate to convert from grams to moles of copper sulfate. Once I have that, then I can convert those into the closest whole number ratio and figure out what that missing number of moles is. How many units of water are there per unit of copper sulfate? Good luck. See you in the lab.